When you're looking for clustering any service, like a web service or database service, you need a load balancer in front of your cluster. Your cluster may contain n number of computers with different IPs and services running on them on a particular port. For example, if you're running Tomcat on port 8080 on your computer and you want to cluster them together, you need to put a load balancer in front of all your Tomcat server. So user will access the load balancer and load balancer will redirect the request on the backend Tomcat servers. There are hardware based load balancer like F5, Cisco ACE. Then there are software based load balancer like you can use HA proxy as a service. You can use Nginx. You can even use Apache service or Squid proxy as a load balancer. But when you're on AWS, AWS provides you a dedicated load balancer which is called as Elastic Load Balancer, in short ELB. ELB is a highly available load balancer spanned across multiple zones, so there is no chance you will lose your ELB or ELB going down. Such kind of scenario won't happen. While setting up any kind of load balancer, you need to be understanding about the ports, the front-end port and the back-end ports. Front-end ports will be the port where it will be listening to the request. Like when you are accessing Google or Facebook, you are just giving the URL. But by default, if you are using HTTPS, by default it will go for port 443. That's the default port for HTTPS. So when you say www.google.com, it goes to the Google's load balancer, which is nearest to your location and will access the load balancer on port 443. Then Google's load balancer will redirect the request onto its backend web servers, and web servers will be running some web services, probably running on port 443 or some other port. Those are called as backend ports for the load balancers. If you're running web service for public usage on the internet, then you would be using 443 or port 80. But if it's something other than web service like mailing service or FTP sites, the front end port of your load balancer will be different. And in the backend, you can have any port on your service. So in our previous exercises, when we set up a Pixie web service, our Pixie web application is running on HTTPD service, which listens by default on port 80. If we put a load balancer in front of it, then the backend port for our load balancer will be port 80. We will see that with an exercise. So our ELB is going to listen on a front-end port and will redirect the request or distribute the request, incoming request, to instances which are under it. And instances can be in any zone. And we will this time use the concept of zone, and we're going to span our application into multiple zones. And we'll put a load balancer on front of it. AWS provides us 3 types of load balancer. Classic load balancer, which is the traditional one, and seems like AWS is going to get rid of it. Now we have application load balancers separately for web service, HTTP and HTTPS, and then we have network load balancer also. So currently we have 3 types of ELB: classic, application and network. So probably classic load balancer will be decommissioned, but this load balancer routes the traffic either at the application level or at the network level. So you can set up HTTP, HTTPS, TCP or any other TCP port also. And it's a very simple load balancing. It listens to the request on the front end port and route it on the backend instances. So this diagram may help you understand. You have a classic load balancer. User will access this load balancer and it's going to route the request either instance in one zone or the another instance in another zone. So instances can be in same zone or they can be in different zones. Now we have a new form of load balancer, application load balancer. This is only for HTTP and HTTPS traffic. It routes the request based on the application at the application level. So it works on the level 7 in your OSI layer, And if you want to redirect a request, let's say you have multiple application in your web service, application named DevOps. So, it can redirect it to different instance, and application named front end that can be redirected to other EC2 instance. So you can use same load balancer and redirect instance to different applications running in different EC2 instances. Then the next kind of load balancer is network load balancer. So if you don't want to use the classic load balancer and you don't have HTTP, HTTPS traffic, you have something else, any other network port like 25 SMTP or any other port, FTP ports, then you can go for network load balancer. Now let's see all this in action. We will set up web services spanned across multiple zones, and we will put a load balancer in front of it. So I have brought back Pixie web server to life, and I have done it from the scratch again, because in previous exercise we removed the AMI, we removed all the instances. So it's a new instance freshly created from CentOS 7 operating system, and there's already Pixie application running on it. And I have also created AMI for it. So we have the AMI ready, and we also have the launch template. So I can launch the next instance also. So let's do that. Launch instance from template. And let's change the tag for the new instance, Pixie Web 02, and launch instance. And let's wait for a minute. So I launched the instance, and if you see, both my instances are in the same zone. That's because I have not selected any preference when I was launching the instance. So I don't want that. I'm going to terminate this instance which is created in zone 1A. I want the next instance to be created in zone 1B. So either I can edit my launch template, or let's see it as we normally launch an instance. So let's go to launch instance, select our AMI, select the instance type. Now here, as we have been skipping this part, now this time we will use it, and we will understand this part more in detail in VPC. But if you see in the subnet section, in the network subnet, here we have two subnet. A subnet is associated with a zone. So this subnet is in South 1A, the another one is in South 1B. So I'm going to select the next one, 1B. Subnets are part of a VPC. Every region will have a default VPC. When we get into VPC, we'll see this much in detail, and we would be not using default VPC later. We will create and set up our own VPC. As of now, we'll use the default VPC and the next subnet. Let's follow the rest of the detail. Or instead of doing that, I could have edited my launch template, but I wanted to show you these settings. Okay, Pixie Web 02 is up and running, and if you see, it's in the another zone, South 1B. Okay, so that's my Web 01. It's in zone 1A. Web 02, it's in 1B. So I have two instances, one in another zone. So even if my zone goes down, not only the instance, even if the entire zone goes down or becomes slow, I have another instance in a different zone. So I get high availability at the application level and also at the network level. Let's validate whether it's up and running, its service. Yes, Pixie application is up and running in Web 01 and Web 02. So now we are going to cluster it, and there is no application level cluster, so we don't need to go to HTTPD and do some clustering. We are going to put a load balancer in front of it. So we are going to go into load balancing section now. there. First, we will create a target group. Target group is simply collection of instances, group of instances. It's very simple to create. Just say create target group, give a name to your target group. So I'll say pixie-tg or web-tg. Target type instances. I'm going to target multiple instances. Protocol HTTP port 80 because that's where it's going to listen on. Both the services on instances are listening on port 80. And that's the default port, so we don't have to mention it. And health check, will come to it. Let's create. So target group is created. Let's add instances under our target group. So click on the target tab here, say edit, select your instances. So I'm going to select both the instances, web server 1 and web server 2, add to registered on port 80 because it's listening on port 80, both the services here. So in our case, front end and back end both port are going to be 80. Save this. So we created a target group. Now it's time to create load balancer. So let's go to load balancer and say create load balancer. As we're talking about, we have three types of load balancer: application, network, and classic. Application load balancer is for HTTP and HTTPS traffic, and it works at the application level. This is an old generation. Classic is an old generation, a previous generation load balancer. Previously we had just ELB, that's all, which was like classic load balancer. As of now, we are going to go with application load balancer. We'll see other kind of load balancer in further lectures, further video sessions. So let's select application load balancer. First, we need to give the name, and this name is going to come in the endpoint of the load balancer. Pixie-web-ELB. So we have two schemes here: internet facing, which will be accessible over the internet. Its endpoint will be accessible over the internet. Then we have internal. If you are doing internal load balancing, let's say web server is redirecting the request to memcache or any other kind of service or database service, and you want internal communication through private IPs, then you can go with internal. And we want a front end internet facing traffic, so we are going to select that scheme. IPv4 we are going to keep as it is. This is the front end port, listener. So we have two protocols, HTTP and HTTPS. Only two options we have in application load balancer, and we can give any port of our choice if we want. If I want, I can give 8080, but that will look little weird if people give the ELB endpoint colon the port number. So I'm going to keep 80, or if it's secure, I'm going to go with HTTPS port 443. You can have multiple listeners also. I can have here HTTPS, but then I'm going to need certificate, signed certificate. You can use self-signed certificate also, or if you have the certificate from some authority, you can upload those certificate, and this connection will come encrypted, secure connection till the load balancer, and from the load balancer then it can go back on the backend instance on plain HTTP traffic, or you can listen again HTTPS on the instance also if you want end-to-end encryption. So we are not looking at any encryption now. We'll be just taking port 80 plain HTTP. Now load balancer will be spanned across multiple zones, and you need to select minimum 2 zones. Anyways, we have only 2 zones in Mumbai region, and we are going to select both. Also our instances are spanned across these 2 zones, so I definitely need to select these 2 zones. Once I do that, I go next screen. Now here it is telling me that your load balancer is not listening on a secure traffic. Port 80 HTTP is not secure traffic. HTTPS is secure, which receives the encrypted connection. We are going to see that later, securing the connection. As of now, we are going to just keep it as it is. security group. There is security group for load balancer also. So we will create new security group here. We will say pixie-web-ELB. Make sure you put the word as ELB at the end. So it's going to be easy for you to identify. So it is going to listen on port 80 and I want it to listen anywhere. So that's the rule I want in its security group. Next, configure routing. Where should it route the traffic when it receives the request on port 80? Here it can route the traffic on a target group, which we already created. So we will say existing target group. We'll select our target group name and we will say register targets. So we have two targets in our target group. Now let's say create. You can review the detail and let's say create. Let's close this and you will see an ELB getting provisioned. Currently it's in provisioning state. It's going to take some time to come up. I'm going to pause the video for some time and come back once it's ready. In a minute or so, my load balancer is active and that's the DNS name. That's the endpoint. You see the name pixie-web-ELB. That's the name of our load balancer that comes in the endpoint. The scheme is internet facing. It's application load balancer. It's spanned across 2 zones. And then you see the security group. We can edit the security group. And there are a few other details that we will edit later. Listeners. So it has one listener listening on port 80. If we want, we can add more listener or we can edit the existing listener. As of now, we are good with it. So let's copy the DNS name and let's try that on from our browser and it's working good. So it's routing the request on web 01 and AWS ELB is round robin load balancer. The algorithm is round robin. So if the first request comes, it's going to go to web 01, second request goes to web 02, third request goes to web 01 again, fourth goes to web 02. So it's going to do round robin. And that's the default algorithm, or should I say only algorithm for AWS ELB. There are instances where your load balancer won't be able to route the traffic to the instance. It could be because of the health check. Now, ELB is going to route the request to instances if it's active, if it's healthy. If it's unhealthy, it will not send the request. So how does it know whether it's healthy or not? It's because of the health check. So let's go and check the health check. Go in target group, health checks. So your target group is going to perform this health check and determine whether your instance is healthy or not. If it's unhealthy, it's not going to route the request. So I'm going to show you that. In target group targets, it says instance status as healthy. Both instances are healthy. I can make them unhealthy. Well, that's very easy. One, I can log into the instance and stop the HTTPD service and it will become unhealthy. But I'll show you one common problem. The common problem will be through security groups. So instance security group, inbound, well, it's listening on port 80 from anywhere. But why should it listen from anywhere? That's not required. I want it to listen only from my IP because load balancer is redirecting the request to it. But when I do this, it will listen on port 80 only from my IP and not from load balancer. Actually, not from anywhere else apart from my IP. Now that will make this instance or under the load balancer as unhealthy. You would be able to access the web service in the instance. Let's confirm that. See, we are able to access from our IP. I am able to access from my IP. I should say that. Let's go to load balancer. Oh, target group, sorry. Currently it's showing us healthy, but it's gonna become unhealthy in a moment. So that's the load balancer endpoint. Refresh that and you won't get anything, because load balancer is not able to route the traffic to the instance. Instance security group is not accepting any connection apart from my IP. So I get 504 gateway timeout. So let's check in target group now. Yeah, our instances are already unhealthy. See that? Request timed out, because target group is not able to reach the instances on port 80 because it's simply denying every request. In such cases, what you can do is, well, you don't need to enable traffic for everyone. Go to the instance security group and add a rule here which says accept port 80 connection from. Now here you can't give the private IP of load balancer because there is none. Whatever IP it gets on the load balancer, it's all dynamic. It's only the endpoint. So but you can't give the endpoint here. What you're going to give is the security group of the load balancer. And this is going to allow traffic from ELB on port 80. So when ELB is trying to access this instance on port 80, it will allow the request because rule says allow it on port 80. Let's save that. But now we have to wait for a few minutes before the target group declare it as healthy. And all this is happening because of health checks. So by the time it becomes healthy, let's talk about health checks. Health checks are performed by ELB for your EC2 instance to check whether your service is healthy or not, instance is healthy or not. Here we have two protocols, HTTP and HTTPS. So we have HTTP and path route. That means if you access the instance with its IP, it's going to show the website. But if the website is inside it, or there are some subdirectory, like let's say DevOps. So if you need to dial in the IP / DevOps, and then your application comes in, so then you have to give here /DevOps. If your application is in subdirectory, but it's in the root directory, so I'm going to keep it as it is. There are so many applications where, so many times where a developer will put your application into a subdirectory, and that time this health check will fail. So you need to give the name of the subdirectory there or the path. Then it's checking the traffic port. Healthy threshold are 5. That means it's going to check it 5 times. If all 5 times it shows healthy, then only it will declare it as healthy. Out of 5, even if it shows 4 healthy, 4 times it checks it's healthy, 5th time it's showing unhealthy. So no, it's not going to declare it as healthy. It will be unhealthy instance. So 5 times it has to respond as healthy on port 80 of HTTP here and /. Then for unhealthy, it's going to check 2 times. If both the times it shows unhealthy, not able to reach, then the instance will be declared unhealthy and no traffic will be sent to that instance. And that should be the case. You should not have like one that's going to be too root, because instances have sometimes high load and they don't respond, but next time you check it responds. So 2 unhealthy threshold is the minimum you should keep. If you want to increase or reduce, you can do that. Now timeout, if it doesn't respond for 5 seconds, that's going to be an unhealthy. It's going to move to the next check. So interval is 30 seconds. So every 30 seconds it is going to perform a check. If you want to reduce that value to 15 seconds, you can do that, or 10 seconds. But I'm going to keep it as 30 seconds only. And it's going to wait for HTTP exit code as 200. 200 is the success code in HTTP. And it's going to rely on the exit code. Well, ELB is not going to, or your target group is not going to open a browser and check. It relies on the exit code that it receives. So if it's receiving 200 exit code, that means it's a success. And these are the health check. That's how it's performed. That's how your target group knows whether your instance is healthy or not. So let's keep the same. And let's go to targets. And you see, it's already healthy now. If you want to test it more further, you can log into any of the EC2 instance and stop your HTTPD service. And then you see that instance will become unhealthy. As of now, it's good. Let's refresh our page. That's ELB endpoint, refresh, and there you go. So load balancer sounds complicated, but actually it's very simple. You just need to be careful about two things: front-end port, back-end port. That's the main thing. And of course, the health checks. Here in application load balancer, front-end ports we have given in load balancer and back-end ports are in the target groups. So we have achieved high availability at the application level. We have 2 web servers and also at the network level, because our web servers are in 2 different zones. And if I want to launch more instances, well, no problem. I have the launch template. I can say action, launch instance from template. Select my template version, 1 single instance or 2. Let's say I want to launch 2 instances. Let's see, only 1. And I'm going to change the tag web03. Also, if I want to decide the zones from here, we have subnet section here and we can select. Now, let's say now we have, this is the 3rd instance. So one is in 1A, the next one is in 1B, the 3rd instance I'll put again in 1A. And we can launch it. So instance is launched, running. Let's just verify its service. It's up. It's time to add it under the target group. So let's go to target group, targets, edit, and let's add. So 2 are already registered over there. So I'm going to add the 3rd one and say save. So 3rd instance is added, web03, but its status, it still shows initial. It's not going to send any traffic. Oh, it's already healthy. Now the traffic will be sent. So like that, you can keep scaling out, or if you don't need it, you can scale in, you can delete it. So I guess you must have understood one very important point with AWS ELB by now. It really doesn't check any load. The name is load balancer, but some people get confused thinking that, okay, probably it's checking the load of the server. And if it's too high, then it's going to send it to another instance which has low load. No, it is just balancing the request. If you see, it's round robin. One request goes to, first request goes to web server 1, second goes to web 02, and here 3rd goes to web 03. If you have 4th request, that will go to web 01. So like that, it will balance the request, and that's how the load gets balanced. That's why it's called as load balancer. So that was really a great show. It's time to wrap up. So we are going to do cleanup. First, we will delete our instances. So I'm going to delete all 3 instances. Or should I say terminate it? Also, I'm going to delete the load balancers. Action, delete. Yes, delete. Load balancer is gone. Target group. When target group is not charged anyways, so even if it's there, no problem. But we are wrapping up, so we're going to delete the target group also. Target group is gone. Instances are getting deleted. And if you're wondering, we have AMI, but I'm going to keep this AMI because we are going to use it in next video lectures. And I don't know why I keep saying lecture. Feels like I'm in a college, but trust me, I'm not a professor. I'm a trainer in DevOps and cloud, and I want to stick to it. So we are wrapping up EC2 dashboard. We have one snapshot that's coming from the AMI, and as I told you, I'm going to keep it for the next session. For this session, that would be all. I will see you in the next one. Thank you for watching.